Good morning, everyone. Good afternoon, good evening, depending on the time you are watching our video. Today, we'll be looking at longitude and latitude. Okay, longitude and latitude is what we have today, and we'll be taking us step by step on how to calculate longitude and latitude, and will also be helping us to be able to know some of the certain areas we need to have our attention focused on. And also, we shall also be looking at some procedures and calculations that are related to longitude and latitude. I believe by the end of this video, you're going to appreciate it so much, because every ignorance and areas of concern will actually be taken care of, and as we move further, you will understand better some of the things that that we are going to do. All right, so let's just guide down straight. This is Jola Team's Educational Consultancy. Stick true to our channel. We are here to eradicate corruption through education, and we're having lots of videos concerning mathematics and other educational career materials or videos that is going to bless you and will also put you into the right perspective. All right, without wasting much of our time, we are going to be going into the introduction. So we are going to first of all be starting by introducing some of the terms, some of those terminologies that are being used in longitude and latitude. All right. So the first thing I want us to see is just the word the longitude. What do we mean when we say longitude? We are saying that longitude is the lines of longitude are imaginary lines drawn on the Earth's surface. These lines are drawn running vertically from North Pole to South Pole on the surface of the Earth. So we say that the lines of longitude are also called the meridians, and they vary from 180 degree east to 180 degree west. That's very important. I want us to take note of that. You cannot have a line of longitude that is higher than 180 degrees. So the maximum degree of longitude you can have is 180. Okay, we say that there is a particular meridian or a longitude, since we've been told that longitude are also lines of are also referred to as meridian. So there is this particular one that is a very crucial, in fact, very, very important to this study. It's called the prime meridian. It passes through the Greenwich in London. So this prime meridian is 0 degree, and it is used as a reference meridian from where the position of other longitudes are measured in degree west or east. All right. Then secondly is the latitude. Latitude. We said the latitude is a circle that is drawn on the Earth's surface, having its center on the axis of the Earth. So the axis of the Earth is the imaginary straight line which runs from the North Pole through the center of the Earth to the South Pole. So all the circles are parallel to each other, hence they are usually referred to as parallels of latitude. So the latitude of a place is measured in degrees north or south of the equator. Latitudes vary from 90 degrees north to 90 degrees south. So what that means is that the maximum degree you can have angle of latitude is 90 degrees. So you cannot have a latitude angle of 92 or 91. No, the maximum you can have is 90 degrees. All right. So we said we have 90 degrees to the north, 90 degrees to the south. Now the line of latitude, which has the same center as that of the Earth, is called the equator, and the equator has a latitude of 0. All right, 0 degree. Okay, so this is a pictorial diagram on what the Earth is all about. So what the labeling is all about. So we have the North Pole, we have the South, we have the parallel of latitudes. Of course, we can see the center of the earth. We can see the prime meridian, which is towards the west. So we have the axis of the earth, and I believe this is going to help us, because when we get to the calculation proper, everybody must be able to know how to identify some of these parameters pictorially, so that, because when you know how to draw when it comes to longitude and latitude, it will going to help you to be able to solve the problems accordingly, and to even see the trajectory, how a particular thing is moving from one position on the earth to another. So it's good to know how to draw, and we are going to be taking us through the drawing process bit by bit. I believe by the end of this video, everybody will be able to draw correctly, and also to do the necessary calculations. All right, so there are things we need to know about this issue of latitude. There is something we need to know, very, very important, that I want to quickly draw our attention to. All right, so the first thing I want us to know, we are saying that how do we identify lines of latitude? Okay, so we identify line of latitude by north or south. So when you see an angle, for example, 45 or 42 degrees north, or you see something that is 36 degrees south, this north and south is one of the things that will help you to identify that this particular one is a latitude line. So we said that, just from the word lie, so it keep on lying from, lying down, they are parallel to one another. Can you see? So it's lying down as we travel from the north. It's lying towards the south pole. All right, so these are lines of latitude. So you see them lying like that from the north to the south. Then also we have lines of longitude. This one is lines that are moving from towards the west. You see them going this way. These are longitude lines. These are longitude lines as they travel side by side. You see them. We have the longitude line that way. Sorry, it keeps traveling. Sorry, that's not very correct, but just have an idea. So what I'm trying to say is longitude lines, you see it when you see something like 72 degrees west, or we use something like 32 degree east. So when you use west and east, you know that this is a particular longitude angle. So we use west or east to identify longitude angles, while we use north or south to identify latitude, angle of latitude. All right. So another thing I want us to know is that from this is 0, of course. This is our 0. When you travel upward towards the north, which from that, this equator actually divided the earth into the hemisphere, the northern hemisphere and the southern hemisphere. So this is from 0. As you travel towards the north pole, you travel at 90 degrees. Then as you travel also downward towards the south pole, you travel at 90 degrees. So you see that from here, from the center. So why is this important? So that when we want to draw lines of latitude that has the same side, for example, I want to draw a line of let's say 32 degree north, and also want to draw 45 degree north. So I will not be wondering which one do I draw first. No, you have to travel. So that means you will get to 32 before you get to 45. So you see, you are going to have here to be 45 degree north, while you have here to be 32 degree north. So you write that you get to 30, because as you travel from 0, you keep going upward and towards the northern side. All right, so that's very important. Another thing I want us to know is that the same thing is applicable to that of the longitude. Longitude, as you travel either to the direction of the west. So you see that you are going to have what we call 180. So as you move from here, from the meridian, now there is what we call the meridian. So as you move from the meridian, you will see that you move 180 degrees, 180 degrees either to the west and 180 degrees to the 180 degrees to the east. So this is very important that we need to know that all right. So later we'll talk about great circles and small circles, even as in the course of this tutorial. All right. So another thing I also want us to know is about the lines of the equator and the prime meridian. Now the prime meridian is actually drawn this way. Have our prime meridian. Is our prime meridian. Okay, so this is actually 0 degrees. So, and we have the equator. The equator also, let's assume these are equator now, which is at the center. Both of them are actually great circles. In fact, the only lines of the latitude that is a great circle is the equator. So later we'll be looking at some of these things. But what I want to score is this is also 0 degrees. So we have here to be 0 degrees. Now, the lines of prime meridian, we call this one the prime meridian. The prime meridian. Okay. So which is having 0 degrees. So it's like our normal Cartesian plane that we used to know. The Cartesian plane, you know, when you have 0, 0 starting from the origin, you know, you have your y, you have your x. All right. So whenever you want to make reference, you plot the point accordingly. Let's assume this is 2, this is 4. Let's assume this is 3, this is 6. All right, so we want to plot a point x, which is 3, 6. You know, it's usually x, y. Okay, so what you normally do is you are going to find 3. Let's say this is 6. You're going to find 6. So where they meet is your point x. So the same thing is how we use the latitude and the longitude. So I mean, sorry, the prime meridian and the equator they are our reference. There is no way you can do without them. You can't do without them. It's not possible. So we use them as reference, just as you know, to be able to calculate or locate any position. So every other angle is measured from either the prime meridian or the equator. So this is very important that I think I should bring our attention to. So whenever we get to calculations, you will be able to know that these are what I need to know. So the prime meridian and the equator, they are our reference lines, you know, to draw other angles. So whenever we want to draw any angle, of course, you have to make reference to the prime meridian, which is 0 degrees, and also the equator, which is 0 degrees. So we are going to be doing a lot of diagram. I'm going to be showing us how do we draw, angles that regards this particular longitude, because it's going to help us a lot when it comes to the calculation in latitude and longitude. Diagram helps a lot. It helps us to see the direction of travel. Then it also gives us a perspective, a clearer perspective of what we are about to do. All right, so we are going to be going to another topic now, which is how to locate places on the Earth's surface. So how do we locate places on the Earth's surface? This is very, very important. Everybody must know how to locate places on the Earth's surface, and that's the next line of action we'll be going through now. I believe you understand how we have been coming from. Most importantly, you must have understand that the maximum angles for longitude is 180. 180 can be either to the west or to the east. Then latitude is 90 degrees south or north. So whenever you see north, south, you know that's latitude. Whenever you see west and east, you know that is a longitude line. So it's important for you to know the difference between these two, the latitude and the longitude, so that everybody should be able to identify these lines. And I see you in the next line of action. So we are going to now go to how do we locate places on the Earth's surface. I believe you are going to please keep watching and subscribe to our channel, even as we take you through the basics of longitude and latitude. Thank you very much. Let's go to the next thing now. All right, so we are welcome once again. Just like I said earlier, now we are going to go straight to what we have, how to locate places on the Earth's surface. All right, so without wasting much of our time, so let's quickly get down to this. How do we locate places on the Earth's surface? And I'm going to be using these examples. I think we're going to do about 4. I believe by the time we are through with these 4, everybody will be able to, we will have been convinced, convincingly be able to locate any place at all on the Earth's surface. All right, now, in this example, the question is locate the position of the coordinates on the Earth's surface. So we have a point A, which is 50 degrees north and 80 degrees east. All right, so just from what we discussed earlier, I was telling us that you will see that when we see north, that's latitude. When we see east, that's a longitude. From our normal Cartesian plane is normally x comma y, x comma y from our geometry. So you see, it's usually, in this case, it's usually latitude comma longitude. So depending on how they decide to do that. All right, so how do we locate point A on the Earth's surface? All right, so this is our Earth. The first thing to do is for you to draw your sphere and locate the axis of the Earth, the north that runs through the north and the south pole, and of course your west. So what we have here now, we have the 50 degrees north. So that means you are going to draw it towards this northern side, towards the northern hemisphere. So just any convenient, you don't need to measure anything, just have a convenient arc, and this is your 50 degrees north. All right, so another one is 80 degrees east. So you come towards the east, and then you take your what is it called now, you take your arc down, your line of parallel. Now the point of intersection, this is the point of intersection, that happens to be your point A. So you see, it's that simple. So usually we used to label this, this is 180, so that we can differentiate it. So this is 180 degrees east, and this is 50 degrees north. So that's point A. You see, it's very easy. All right, let's look at another one, which is 65 degrees south. So meaning we are going to come towards the southern side, the southern hemisphere. Take any arc of convenience. So this is latitude because it's south. So this is going to be 65 degrees south. Okay, and we have our longitude, which is 105 degrees west. So come towards, we are going to draw it towards the west. Okay, so where they meet, the point of intersection actually happen to be our point X. I believe you understand this. So let's do one more. Let's do another one. Let's see. I believe by the time we do this, we are going to know. Now look at this one also. This is we are looking for point H. H is actually 23 degree north. So 23 degree north. So to do 23 degree north, of course, just find a convenient arc. Okay, this 20, just label this 23 degree north. Okay, and we have 76 degree west. This is 76 degree west. All right, so that's the point of intersection. So this is our point H. Good. Then the other one is 87 degrees south. 87 degrees south. So sorry, that's that I'm to the north pole, so that's incorrect. It should be to the south. So south actually is the southern hemisphere. So you come down here and draw a convenient. This is 87 degrees south. All right, and 106 degree east. So from here you also go down to this, and this point of intersection actually is our point Q. This is our point Q. So you see, it's very easy to locate. It's very easy to do. It's not something difficult at all. I believe we enjoy this. All right, so let's go to another aspect, which is how to calculate angles between two places on the Earth's surface. So everybody must be able to know how to calculate angles on the Earth's surface. So let's do that. How do we calculate angles? It's very, very important, because it's going to help us even when we get to calculation proper, when we are calculating distances along great circle, along parallel of latitudes, and so on and so forth. So let's quickly get down to this. All right, so I quickly want to show us this. There is this calculation code that will teach us. This really help us when you are doing calculations as regards angles between two places on the Earth. All right, when you are given two angles, maybe whatever later we'll be looking at, just know that whenever you see north and north, maybe what you have, the difference you are finding, later will tell us the way longitude and latitude are given. One will be fixed, one will be varied. So later we'll look at that. But when you see north north, you minus, south south, you minus, east east, you minus, west west, you minus. But when it's north south or south north, whichever, there you add. When it's north east, when it's east west or west east, you also add. So that's how to find location. Now, for example, in this case, I can see east east. Now, for example, I can see east here, and this is east. So to find the angle between these two locations, because it's they are the same, east east. So what I'm going to do, I'm going to minus. So this one is going to be 115 minus 64 degrees. So that will go, that's what you are going to do. So you are going to have 114 minus 64. So why? Because it is east east. East east. Are we following me? So we must be able to know this, that whenever you are asked to find the angle between two locations, so you just check the ones that they are varied. Later we'll look at other examples. What is going on? Is it the same? Is it different? And we mean whether the north, whether it's east east or south south or southwest whatsoever. So like in this case now, we subtract. We are going to have our 51 here degrees. That's just the angle difference. Here we can see west, we can see east, so they are not the same. So just like west east, so you have to add. You just add that. It's going to be 22 plus 76 degrees. All right, so this is what we are going to do. And when you do this, it's going to give us 98. This is 98 degrees. All right, so in this case also, this is north and south. So north and south is going to give us another one. So we are adding because they are not the same. So we are having 32 added to 67 degrees. All right, so that's also 99. Okay, it's going to give us 99 degrees. Then also this one, south south. Now this is the same. This is south, this is south. All right, so that's the same. So that means we are going to subtract. So we are going to have 56 subtracted from 41. This is 5 and this is 1. So this is going to give us 15 degrees. So you can see this is just how, once you've mastered this calculation code, you see that it's become very easy for you to do. You'll be able to know what and what to do. All right, so let's quickly look at one more of different type. Now in this case, we are to calculate the difference in longitude. So why do we say longitude? Now you will discover that what is it called now, the latitude are fixed. Can you see? The latitude is 41 degrees south and another one is 41 degrees south. So it's a fixed latitude. So you see the latitude is the same. See, they've made it fixed and fixed. So the only thing that vary is the longitude. So is that one you are going to find the difference. And I want us to quickly see how we can locate this. Let's just to do a refresher course on what we have done before. So we have 41 degrees south. 41 degrees south, that's a fixed, that's a common latitude that they have. So we have 41 degrees south. All right, then we now have 32 degree east. So 32, you come towards the east, you come towards the east, and you come towards the east, then you take that. So we have okay, say this is our 32 degrees east. Okay, then we also have 10 degree. You see now we also have 10 degree east. So in this case, 32 is going to come before 10 because you move from 0 from the meridian down to this way. So okay, so we have this, and let me also, maybe later I will show us something very, very important. Oh, sorry, that's not I want to show us something very important when it comes to this issue of drawing lines of longitude and latitude. Now, because you see, because you have drawn two longitudes, right? So you have to, there's no way you can draw these two longitudes without the prime meridian. There's no possible. Just like what I discussed with us earlier, this is our reference. So, and this is our fixed latitude. So because latitude is fixed, good. You may not need to show, the, what is it called now? You may not need to show the equator, but because you are drawing, what is it called? You are drawing longitudes. You have drawn 1 or 2. So there is no way you can draw two longitudes without taking the angle from the prime meridian. So that's why you need to show the prime meridian. And you see, at this point, this is where we have, this is our 103 degrees east. All right. So 10 degree east is our point Q. So this is point Q. 32 degree east and 41 is our point P. So this is point P. Okay. Now, so now the next thing to do now, you are going to join these points to the center. Now look at it. This is where even the prime meridian. This is where the prime meridian are intersected with the line of the common line of latitude that they have. So we are expected to join them. You draw a straight line there to join this from here also to this point, and from here also to this point. So you are expected to do this because it is from this line you are going to reference point P and point Q. Okay, so it is from that line. It is from the line. This one from the meridian. This is actually 0 degrees, which is our meridian. It is from there you are going to join this. I want everybody to be able to know how to draw lines of you know, how to draw the angle, a given angle. How do you draw it? It's very important that we learn this. Now, there's also a cross-section diagram I want to show us. If you view this from above, maybe you just cut it through. What are you going to see? Now, this is, this usually, let's use M for this. So what is going to happen is that this place that we have W now, the west side is going to carry my W. Then you see, we have other points that is away from it. So we are going to have, maybe this point is our Q. This point is my P. So this is P, this is Q, and this point, this is my M, which is the 0 now. So you see, now from here now to, so it's from here I'm going to take all the other references. So from here to Q, that's my 103. Then from here to P, that is my 32 degrees. All right. So now, how do we now find the latitude difference? I mean the longitude difference. You look at the letter. This is east. This is east. So because they are the same, what do? We subtract. We subtract. So 103, of course, the bigger one minus the smaller one. So minus 32. This is going to give us 1, right? Okay. This 1. Then we take this. This is 9. So that's going to give us 6. Right? That's 6. Okay. So that's going to give us 10. Let me just say 10. This is 7. Okay, so if we subtract this, you are going to have 71. All right, so this is the next question we are going to be looking at. Okay, so this one actually is asking us to calculate the difference in longitude. The first thing you are going to observe, you are going to see that the latitudes have been fixed, that this is common. They have a common latitude. The way coordinates of location is given, one is usually common. There will be a common either latitude or longitude, which is, we normally say that's fixed. Then why the other one will be varied depending. In this case, the latitude is fixed, while the longitudes are varied. So we have different longitudes. So because the longitudes are varied, so that means for you to draw those two longitudes, you must first of all draw your reference line, which is your prime meridian. Okay, so let's say this is our prime meridian, where other latitude longitude will be drawn. So this is usually 0 degrees. Okay, all right. So now, before we now continue, now we see that we are having 60 degrees north. Okay, so I can come to the northern hemisphere and have my 60 degrees. Okay, then again, I have 18 degrees west. Okay, so I can take my 18 degree west. Okay, so you can label this 18 degrees to the west. Okay, yes, then we have of course, we have a 53 degree east. So let's take our 53 degrees east. Okay, so this is 53 degrees east. All right, so of course, you are going to complete the common latitude line that they have, so that I can get the center. So it is from this center. So we have our points. This is the meridian. This one with 18 is X. Okay. Then this one with this is our 53. Of course, that's Y. Okay. So you are going to join each of these lines to the center of this particular common latitude. So you join them. Okay. So this is what you are going to have. You are going to have this. So you see that it is from this meridian. If you move this way, you move 18 degrees. If you move this way, you move 53 degrees. So that's how you do. We make sure it's from this prime meridian we are doing our movement. All right. So I want to believe we understand. So the difference is going to be this. Now let's look at it from the pictorial point of view. If I happen to use this line, for example, if this happens to be my meridian, which is 0, okay, so I'm going to have on this way, which can be my X. I'm going to have another one this way, which is going to be my Y. Okay, so you see that from here to here is going to be 18 degrees, and from here to here is going to be 53. All right. So the difference in angle will now be here, which we usually refer to as the theta. Okay, so what do we do next? We now begin to check. This is the varied longitude. We have west, we have 18 degree west, and we have 53 degree east. So they are different. So the letters are not the same. One is towards the west, one is towards the east. So from the code I gave us earlier, that whenever you have two letters that are not the same, we usually add them together. So that we are going to add this. To find the difference between this now is going to be 53 added to 18. So because the letters are not the same, so that's 1. This is 6, 7. Okay, so that's 71 degrees. So that will be the angle. In other words, the angular difference between, which is the longitude difference between these 2 points, is going to, in other words, our theta is going to be 71 degrees. All right, I believe we understand that. So let's do one more. Let's see another one. Now this is we also we're also asked to find the difference in longitude. Okay, so the first thing you check, the latitude again is fixed, is common. So what is varying is the longitude. So that means we have, the first thing I will do, I will need my my prime meridian, of course, to be able to locate those two longitudes. So I have my prime meridian. This is my prime meridian, which is 0 degrees. Okay, then the next thing is to draw my 102 degree east. So I'll come to the east and draw my 102. Let's find a convenient side. This is 102 degrees east. Okay, so what about their common latitude? Their common latitude is 33 degrees south. Okay, so let me just come to the southern hemisphere and have my 32, my 33 here. So I have 33 degrees south. All right, so I can see a point of intersection here. That's my position A. All right, this is also a position, but is on the prime meridian, so we can use letter M or whatever letter you want to choose to use. And we also have 67 degree west. Okay, so from here now, from the meridian, I'm also able to take an angle. I'm also able to take an angle down to this point. Okay, let's assume this is my 67 degrees west. Okay, so I can see my point of intersection here also. This is my B. This is my point B now. All right, so of course you are going to complete this the common latitude that they have. You complete so that you can locate the center. Okay, once that center is located, then you have to join the point to that center. You join it to the center from here to here and from here to here. All right, so that's what it's going to be. So the cross section now, if you look at it from above, what are we going to see? We are going to see my line. Let's assume this is my M. You know, I like using that straight one because it's just like your Cartesian plane. You know, it's usually straight. So that's like my y-axis from a 0 origin. So then from there, I was able to see one angle coming this way, another one going up that way. So depending on what you label, okay, towards the south is my A. If you look at that diagram, towards the south is my A. Then towards the west side is my, away from the west, or towards the west rather, is my my B. So you can have it like this. Okay, then from this 0 to this point to A, that's where I recorded 102 degrees. Then from here to here, from Z, it should be this way. In fact, the arrow point should go from this prime meridian to that side, which is my 67. That's my 67 degrees west. Okay, so that's it. So okay, so why the angular difference, which is longitude difference, will now be the total. If I include all the two together, that would be the angle difference. All right. So, but now what do I do? How do I get that theta? I will check this. I have my 102 east. I have another 67 west. So they are not the same. They're actually not the same. So since they are not the same, so what I need to do now is to add them together. So just like I told us before, once they are not the same, you add them. So 102 is being added to 67. So this is going to give us 961. So we are having 169 degrees as the difference in longitude between these 2 points. I believe we are understanding how this is done, most especially when and how to draw the meridian. You see, whenever you are given any points, maybe 2 points, the first thing you will check which one is fixed. You see, this is 33 degrees south. This is 33 degrees south. All right. So once you have seen the one that is fixed, then you now check which one is varied. Of course, if one is common, the one that, when I mean fixed, I'm actually referring to the common. They are going to have one of it to be common. Either the longitude will be common or the latitude will be common. depending on what is here. So that's what I mean when I say fixed. Now in this case, you see that the latitude is fixed. It's just 33 for point A. It's also 33 in point B. And when I say fixed also, the letter must be the same. This is south, south. It's not that if this one is 33 degree east and this one is 33, for example, 33 degrees south and this is 33 degree north, then it's not fixed. It is varied. So when I mean fixed, I mean both in the direction. So you see that this is 33, the magnitude is 33, and the direction is also the same. So they have to be correct in that form. I believe we have understanding it. So if the latitude is fixed, you don't need to worry about drawing the equator. Do you understand? Because you are not drawing though some people may say, there's still need for you to draw. But no, if you not even make the diagram it can make it too confusing and cumbersome. But, but the one that you draw, you have to draw 1 and 2. It's like in a Cartesian plane, when you have, maybe the value of X is fixed. Or the value of Y is fixed here. So what happened? And you're having different values of X. You see, we are going to be plotting the graph that is looking like this. So you see, we said this is a zero graph, right? We say which one? Because it's not showing any, but yeah, this one works in longitude and latitude. So in this case, it is the longitude that is fixed. Then we can also have another scenario where the latitude is fixed. So you are having these different points, hitting it like that. So this is our Y, this is our X, just like it. So you see, we say this is a zero graph that is not showing any correlation. But what I want us to see is that when the latitude is fixed, then you have to draw the longitude that varies. Then you have to draw the prime meridian. If the longitude is fixed and you have to draw 2 or more latitude, then you have to draw the equator. We'll be looking at that shortly. And another, how do we draw if in a scenario where we have the latitude fixed and the longitude fixed and the latitude varied. So we'll be looking at that so that we'll be able to see how do we draw this diagram. I actually want every one of us to know how to draw this diagram. It's going to help us a lot. And you are going to enjoy it, to make calculation interesting to you, because you can easily see pictorially how to navigate through. So this is very important. That's why usually I normally draw the cross-section diagram to show what is happening here. Is that you are cutting through and you are looking like a plan view. You are trying to see how will this thing look like. So this is what this one is showing us. This one is showing us a plan view of what we are seeing here. What is going on? It's like we cut it through. Then we look from above. Then we are able to see, like a sector. Actually, most of the times, all what you'll be seeing is a sector. You'll always be seeing a sector, depending on different forms. So I believe we enjoyed this. All right, so we are going to be taking the next one now, and in this case, we are going to be looking at a scenario where the longitude, we want that the longitude is varied. Is fixed. That is common, and then the latitude now is varied. So let's see how do we draw that and how do we calculate the difference in their angle. How do we calculate that when it comes to this particular type of scenario? So we have been able to look at the longitude being varied and latitude being fixed. We have done several examples. So now let's go to the one for fixed longitude and varied latitude. I believe we are enjoying this video and we are actually learning. Please, if you have any question, kindly drop it in the comment section so that I can look at it and address as appropriately. If it's and also I believe we are also following the trend, the way we are moving gradually. We are not too fast. We want everybody, a lame person, to even understand bit by bit of what we are doing, even as we mount our wings, to soar higher. Gradually, at least step by step. It's good for us to know this. All right, I believe you are enjoying it. So let's go to the next example. Thank you very much. Keep watching. God bless you. All right, so here we are. This is another question, just like what we discussed before. In this case, you will see that we have our latitude. Now you see, this is what I was trying to explain to us the last time. You see, the longitude now is actually fixed. You see that it is common. They now have a common longitude and a very different latitude. All right. Now, because I'm going to be drawing different latitude, so that is going to make me to indicate my equator. You know, the way we normally do before, we indicate our prime meridian. So, but for now, because the latitude is varied, it's not the same. So the equator must be the reference that I'm going to be using to draw other ones. Okay, having done this, all right. Now, some people may say, why can't I put the what is it called now, the prime meridian too? No, it's going to, it's not that it's not correct, but it's going to make our diagram very confusing. But you see, when you have this, you are able to see the major thing, what is actually needful in this particular matter. Now, if you look at the points we are giving, we have our latitude that is 73. So we can have any convenient point, any convenient side and draw. Okay, let's say this is the common longitude, which is this. Okay, now this point that this intersection that we have here is not either of the points, so let's call it M. It's just where the equator intersected with the 73-degree east longitude line. All right, so let's not take the latitude. Let's have our latitude. Now we have latitude 15 degrees south. So right, so if I come to the southern hemisphere, if I'm at the southern hemisphere, I can just take an arc, okay, and this is my 15 degrees south. Okay, then the other one is look at this. This is 78 degrees south. You see, now both of them are to the south, but which one, how do I locate this? Now, don't forget that I told us initially that when you are coming from what is it called? We are coming the line of latitude from 0, you move upward 90 degrees, you move downwards 90 degrees. You see, this is one of the reasons why it's good to know that. So now, meaning if I'm going this way, is 0, I'm increasing. So that means this very one that I've done, we have to be up. So you see, so that means this one we have to be actually up. So mine is 87. So let me change this one to 87. Let this one be the 87. Why the 15 will be a little bit, will be up here. Okay. We are understanding it, because if you are traveling from 0 to 90, you will get to 15 before you get to 87. So 87 will be closer to the southern pole compared to the 15. So I believe you understand that. All right, so I have my locations. This is where I have the 15 is my Q, and where I have my 87 is my R. All right, so what do I do next? Now, all these 3 points, we now join it to the equator. You join them to the center of that circle. You join them. So you see, this is how you are going to be. You are going to join all of them together. So we have this, we have this, we have this. I believe we are understanding it. So even if I come to the cross section, this is still my M. This is still my M. You see my M in this case is up, while other ones are downward. So it's going to be something like this, something like this, if you look at it from the top. So this is M, this is Q, and this is R. You see, so this is from here to here. That's from my M to Q, that's 15 degrees, and from here to here, that's 87 degrees. See now, why the whole of here will be my theta. All right, so I believe we are understanding this. Please let me just have a question in the comment section, just in case you want me to clarify anything. Now, how do we now find theta, which is the difference in latitude? That's our theta. Now, the theta, to find the theta, we look at the direction of the latitude that we are given. This one is towards the south, this one also towards the south. And from the code, we say when it's the same, when the direction is the same, we subtract. When the direction is different, we do what? We add. All right. So in this case, the direction is the same, south-south. So the letter SS. All right. So when it's south-south, we do what? We subtract. So we are going to be subtracting 87. We are going to subtracting 15 from 87. Okay. This is 2 and this is 7. Okay. So the theta angle, which is the difference in latitude, is going to be 72 degrees. All right. So let's take another question. Let's look at another. I believe we are understanding this. Please, if you have any question, kindly please, so let's look at this. This is question 5. Let's see this again. I believe the more we do, the more we gain mastery. All right. So now in this case again, what are we seeing? We are seeing that the longitude are also fixed. You can see fixed longitude. You see, this is 73 degree east, 73 degrees. Okay, this is similar to what we have done before. Okay, so let's look at this. This one now, we have this longitude to be different. I mean, the longitude is actually fixed, common. Can you see? This is 104 degree west, and we have our latitude to be varied. All right. So because latitude is varied, again, we draw our equator. Okay. Just okay, so that we can locate the center. Now that the equator is done, is drawn. So what is next? I have my latitude 49 degrees to the north. Okay. So this is my 49 degrees to the north. All right. Then I also have 33 to the south. I have 33 to the south. Okay. Now, they now have a common longitude, which is what we normally say is fixed. That is 104 degree west. So from here down 104 towards the west. Just make a convenient one towards the west. This 104 degree west. All right. So what are the intersections? I can see first intersection here with 49. That's point B. The second one, which is 33 to that 104 longitude, is my D. So this is point D. And of course, this is where the equator also meets that common, which is our M. Usually we use M. So the next thing to do usually is to join the points. Okay, so let me just join the points. So from here, I believe you can see this. Okay, that's one. Then again from here, we join these points to this. Okay, then again, we join another point to this. Right. So you see, this is what we are able to see. You can see that from the center of the circle, which is the equator now, that's the reference. So all points must be coming from there. Okay. So I believe we are understanding this. I believe very strongly that we are understanding what we are doing. Okay. So what do we do now? How do we now do the calculation? If you want to look at the cross section, just like what we normally do, this is the center. Maybe this center O. Maybe we label this one O. Of course, this place will be O also. Then from O, I can see, usually this is my straight line. If this is my M, if I decide to use this as my M, okay, then above my M, I can see my B. And below my M, I can see my D. Okay. If I'm looking at it like a plan view. So from here to here to D now, the angle there is 33. Then from here to here, the angle to B is 49. So you see, then why this is our difference in latitude. This is theta. All right, so how do we get theta now? So to get theta, we simply say the very one, we have 49 degrees north, which is and 33 degrees south. So we are seeing different directions. So when it's different direction, we add it together. So we are going to do 49 added to 33 because the direction is not the same. So we can see north and we can see south. So we have different directions. So when we have different directions from our code, we say you add. When the direction is the same, you subtract. All right, so when we do this, that's 12. This is 7 and 8. So this is 82 degrees. So in other words, our theta is going to be 82 degrees. So this will be the difference in latitude. I believe we enjoy this and we are understanding it. Please, this is very important. In case you have any question, in case you are confused anywhere, please kindly let me know by dropping something in the comment section. Please also encourage us by liking and sharing, and also subscribe. Please kindly subscribe to our channel. When you are doing that, you are encouraging us, to do more and to improve area of our weaknesses, area we need to put in more effort. Please comment like that will be encouraging. Please kindly do so, and God will bless you. So I believe that we are enjoying this. We are going bit by bit. We are moving gradually till we get to the major issue. You see, but it's good to start from the foundation. That's what we are actually doing. We are trying to ensure that we carry everybody along from the foundation. So from the foundation, then we begin to move gradually. I think we should still do one or more questions on this, so that for us to gain mastery, as many that are still having the area of confusion, maybe I can still do one or two more examples just to show us more on how this thing is done. And I want us to pay particular attention to how this thing is being drawn. Just to, for emphasis sake again, I told us whichever is fixed, you check. You know what I mean by fixed now? I mean the common ones. In this case, we have the longitude to be common. So you see that is the longitude, both in magnitude and direction, is the same. So that means it's common. Okay. And we also have that, excuse me, also have that, then the one you are going to check that they are varied is the latitude. So because the latitude is varied, the one that is varied, you now check the reference line. The reference line for latitude is the equator. The reference line for longitude is the prime meridian. So we have equator for latitude, prime meridian for longitude. So because the latitude is varied, so we are going to draw the equator. That would be the reference line they are going to be using to draw other latitudes. And if it's the latitude that is fixed and the longitude is varied, then you will need to draw the prime meridian, so that you use from there to now draw other longitudes, or other meridians, as the case may be. So I believe we are understanding it. So please, if you are confused, please just go back to the video and watch the ones I've done regarding other ones. It's very, very important that we get used to this. And okay, let's just take another question. Let's take another example. Let's see, just to recap all this section properly. And I believe we are enjoying it. I believe we are understanding it, and I believe God is actually adding to our knowledge. Okay, so God bless you. Let's take another question now. Thank you very much. Okay, all right, you are welcome. This is the next and the last for this section. After this, we'll be going to radius, how to calculate the radius of the earth. But finally, on how to draw and how to find the angular differences, or what we refer to as a difference in longitude or difference in latitude from a given location, maybe 2 points, maybe I have 2 positions, and we are asked to find the longitude difference or the latitude difference depending on the one that is fixed and the one that is varied. In other words, depending on the one that is common and the one that is not common. So that's exactly what we have been doing, and I believe from the previous examples we are actually catching on well. We are understanding how this is being done. So I'm also believing that we are not having any issue, which is very, very important. I want us to be able to know how this is done. Please, let's go back to the video and also look at how the reason why I'm doing what I'm doing and ask questions. Please, it's very important to ask questions. And I'm trusting God to also help me to be able to read our minds ahead and to be able to explain in details, areas that we are having, we are getting confused. All right, so let's do this final one regarding this particular aspect. Okay, so we are in this question. We are asked that what is the difference in latitude? What is the latitude difference? So that means they are actually asking for the angle, the difference in the angle between these two points. All right, point X and point Y. All right. So the first thing to look at when you are given point like this is to check which one is fixed and which one is varied. That is, which one is common, because one must be common. Now look at this question. You will see that none of them, you see, this is 14 degree east, 12 degree north, 28. You see, you can't find any common, what's it called now? Either latitude to be common or longitude to be common. Do we get this now? So whenever you see a question like this, that is not correct. You can't have points when you want to locate a place on the surface of the earth without having one of them being fixed or common to both sides. Are we getting it now? So I want to believe this was actually typed in error. So let's just have a scenario where this is let's say this is 28. Let's say this is 28 degrees. 28 degrees degree east. Okay, now it's making sense now. It's making sense now because we can now have at least two locations, 2 points that is common, and in this case is the longitude that is common. All right, now that the longitude is common, that means the one that is varying is the latitude. All right, so meaning that will now make us to go and draw first the equator. Okay, so you need to draw the equator because you can see that, and of course we are doing this so that we can get the center. Okay, this is a line, it's a circular line that goes even behind this particular globe. So that's why we are using dash continuous line to show the view that there is a particular hidden line behind. All right, so this is our equator. Then the first point that we have here is 86 degree north. So just very quickly, you can just come here, have your 86 degree north. Okay, and we have the common longitude is 28 degrees east. So let's just draw the common longitude. Okay, let's say this is our 28 degrees east. Okay, this is the common longitude that we have. Then also we on the second side where this one meets actually happens to be our X. So the next one is 12 degrees north. 12 degrees north. So this is this point is X. I believe you agree with that. Then the other latitude that we have is 12 degrees. So we are moving from 0 this way. So 12 can be somewhere here. Let's have 12 close to the equator. This is 12 degrees north also. All right. So at this point, this is where we have our Y. Okay, this is where we have our Y. All right. And this is where we have the equator intersecting with the common longitude. So we usually use letter M to represent that. I believe we are understanding this. All right. So the first thing I want us to do now is now to join. You are going to join this point to this center. You join it. Then again, you join this one to the center of the earth. And of course, you join the third one. You join the third one. You join this third one also to the center. So you have to join all the points that you have positioned like this. So you see, you have to join all of them together. It's very important. So these are the 2 points we are giving, but we make reference to your equator, because all these angles are gotten from you start referencing from the equator. So you have to show the equator that you use. I believe we are understanding how these things is being done. So it's important for us to please know this. So if you have any questions, so you see that it is from M that you have this angle. It is from M that you also have this angle. So you have to understand that it has to go this way. All right. So this is it. This is the diagram. This is how you can draw the diagram. It's very easy to do. Don't forget, when you look at the one that is varied, then it means you have to get the reference of that varied one. For example, here now, the latitude is varied, so I need the equator to be able to draw it. If the longitude is varied, then you need the prime meridian to be able to draw it. So you show the prime meridian to now indicate other varying longitude. But if you have a varying latitude, you will show the equator to now reference other latitude. So that is just as easy as that. Then whatever you do, you make sure you throw them. Now something is very obvious. You see that whenever the latitude is common, whenever you have a common latitude, you will see that you always have your all your points on the small circle. The other time I said I'm going to talk to you about small circle and big circle. Now all lines of longitudes, in other words, meridians, they are all big circles. So they are big circles. So it is only the equator that is a big circle. Only the equator. So big circles, we have the equator and all meridians. All meridians are big circles. But only the equator is other parallel lines are small circles. So all right, so let's quickly just round up this. If I want to show the picture, if this is my M, okay, and I have other 2 points towards the north. You see, towards the north. So I have the first point, that's my Y. I have another one, that's my X. So this X, this is Y. From here, from my M to Y, that's 12. That's 12 degrees. Then from from M also to X, that's 86. That's 86 degrees. So how do I get this angle? Then I'll check. This is north. This is north. So their direction is the same. So I'm having 86 degree north and I'm having 12 degrees north. So you see the direction is the same. And from our code, north we minus, SS we minus. Once it's the same, once you have the direction to be the same, you subtract. When the direction is different, you add. So in this case, we are subtracting because the direction is the same. So we have 86 minus 12. So when you do this, it's going to give you 4 and it's going to give you 7. So we have 74 degrees. So the difference in latitude now, which is your theta, difference in latitude, which is our theta now, is going to be from what we have solved, is going to be 74 degrees. So I believe we understand how this is being played out. It's not a difficult matter at all, and all we need to do is just to understand the basics, then try as much as we can to see how this is done. So once you know how to draw the diagram, then you see that the calculation becomes much in fact easier for you. So once you know how to do, especially this cross section is just as if I slash it this way. I slash it open, then I look from the west side, slash it open just like an orange. You just put a knife from the north, then you take it down like that. Then what can you see here? You see, you view it from this way. Then once that is done, you see that you are going to be seeing something like this, you know, that is there. So, and that's the cross section. So it's very easy for you to draw lines of latitude and longitude. So you just follow this pattern, and don't forget the code. And I think this is going to help us. I believe we understood this. I think it's going to do help us very, very well, even as we move ahead to the next one. So we'll be entering calculations now. We're going to be looking at calculations proper now. Since we can now know how to draw, then we are going to be looking at how to calculate radius of the earth. We'll be looking from little derivations, provings. Then we also look at distances now. We're going to be looking at how do we calculate distance along great circles, along parallel of latitudes. And also we are also going to be looking at time, the longitude and time. These are some of the things we are going to cover in this video. We are going to look at how do we calculate longitude and time. You see, when you are given time, how do we know the time difference between two locations, and so on and so forth. So we'll be looking at all these in the course of this video. Please don't give up on us. Just keep on following. Forgive all those of us that are genius. I know some people are genius. All these ones are formally very, too easy for you. But please just have to understand that there are people that are still crawling, that are yet to start working. So we need to carry everybody along till we get to that aspect of expert, where everybody can now flow together. So we want to make this as simple as possible, and we want to start from the scratch. Then we start building it block by block. All right. So I'm believing that we are understanding this as we progress gradually. All right. See you in the next video. God bless you. Please subscribe, share, and also like. We are doing that. You are encouraging us to do more. God bless you. See you in our next video. Thank you very much.